Lesson 12.3, Task 1. Solve rational equations graphically. You have previously worked with rational expressions. A rational equation is an equation with one or more rational expressions. These equations can be solved algebraically or graphically. All right, consider the rational equation 3 divided by x plus 1 equals 3. Rewrite the equation so that one side is 0. Let the non-zero side of the equation represent g of x. All right, so g of x is going to equal 3 over x plus 1 minus 3. All we have to do is subtract 3 to the other side. All right, so it says what transformations map the graph of the function f of x equals 1 over x to the function related to the non-zero side of the equation. Okay, so remember 1 over x is your parent function. This is the most basic form of a rational equation. So if we look at the one we have a 3, we have a plus 1, and then since we subtracted 3 to the other side, we also have a negative 3. So the number on top is going to be a vertical stretch or compression. The number here next to your x is going to be a horizontal shift, and then the minus 3 that we moved over will be a vertical shift. All right, so it says, what transformations map the graph of this function to the function related to the non-zero side of the equation? So the vertical stretch of a factor of, you can see that that's going to be a vertical stretch of 3. And then a horizontal shift, so we're going to shift it left 1, so minus 1. And then we're going to have a vertical shift down 3. All right, so left 1, down 3, and a vertical stretch as well. All right, so those just come from the numbers right here in the new function. That's the transformation of the parent function. All right, select all the values for x for which this equation is undefined. Remember, it's undefined if there's a 0 in the denominator, so we cannot divide by 0. So negative 1 plus 1 equals 0, so x cannot be negative 1. How does this relate to the transformation in part A? All right, it relates to the transformation in part A. All we did was subtract the negative 3 over. So it should be pretty much the same excluded value. Let's see what they say here. It means there's a vertical isotope of the graph of the parent function is translated 1 unit to the left. So x equals negative 1 is where your isotope would be for the transformation. All right, so there's a picture here. Here's the image of this, and you can see how the graph has been shifted over. And there is your dotted line. This is really just an imaginary line that these graphs are approaching. And we have these here just to help sketch the graph. So this vertical isotope of negative 1 comes from the denominator here where the excluded value was. All right, it says the graph of g of x equals 3 over x plus 1 minus 3 is shown. What is the x-intercept? Is the value of the x-intercept an excluded value? All right, so the x-intercept, here's the x and y axis. The x-intercept is 0. And no, that's not an excluded value. The only excluded values would be here at the isotopes. So 0 is the x-intercept, and it is not an excluded value. All right, how do you use the graph of g of x to identify the solutions of this equation? What is the solution? All right, so the x-intercept is actually the solution. So the x-intercept was 0, so that is your solution. And you can see there's two pieces to the graph, but you can see that this one is not going to cross the x-axis at all. There's another horizontal isotope here at -3, so this piece will never get close to the x. So even though this graph has two pieces to the function, it only has one solution. All right, so it says consider the rational equation 2 over x minus 4 minus x equals -3. All right, so they've given us a new function here to look at. Notice that if you add x to both sides of the equation, you have a simple rational equation on the left and a linear equation on the right. So we'll have 2 over x minus 4 equals x minus 3. All right, so rewrite each of these expressions as a function. How could you use the graph of two functions to solve for x? All right, so if we have 2 over x minus 4 equals x minus 3, we could set the left side equal to y1 in your calculator, and we could set the right side equal to L2 or y2 in your calculator, and we can find the intersection points of those two graphs. All right, so it looks like they've graphed these two lines for us. So the rational part would be the two curved lines. That would be your 2 over x minus 4. And then they also graphed x minus 3. So here's the equation x minus 3. You can see the y-intercept and the slopes. And this time, this equation has two solutions. You can see they intersect at 2 and 5. So whatever your x values are, that would be the solutions. So for the graph f and g, for what values of x do these two intersect? Okay, select all values of x. So it says for what values of x does 2 over x minus 4 equal x minus 3? So that means where do they intersect? And we already seen they intersect at x equals 2 and x equals 5. All right, are these values excluded values? How can you check your answer? All right, so the excluded values would only come from the isotope here. So that would be x equals 4. And again, 4 came from the denominator here. 4 minus 4 equals 0. That would be your excluded value. So no, these two x values, 2 and 5, are not excluded values. All right, that's all for task 1. If you have any questions, please let me know. Lesson 12.3, task 2. Solve rational equations algebraically. You can solve a rational equation algebraically by first multiplying each side by the least common denominator of the rational expressions in the equation. This method eliminates the fraction and produces a polynomial equation that you know how to solve, but it may yield extraneous solutions that are excluded values for the original equation. All right, so it says solve x plus 4 over 5x minus 5 equals x plus 7 over 3x minus 3 algebraically. Identify any excluded values. All right, so the first thing I'm going to do is I'm going to rewrite my equation over here. So I'm going to have x plus 4. Well, I said x plus 4, and then that's not what I wrote. So let's try that again. X plus 4 over 5x minus 5 equals x plus 7 over 3x minus 3. All right, the first thing I'm going to do is go ahead and factor my denominators. So I can see that these have a common factor of 5. So if I factor out a 5, I'm left with x minus 1. So I just rewrote that in factored form. And then I'm going to do the same thing over here, except I'm going to pull out a 3. So I'm going to have x times, or 3 times x minus 1. And again, I just rewrote that in factored form here. All right, now I can see that they do have a common factor. They have x minus 1 in common, but we need a common denominator all the way across. So 5 and 3, both are multiples of 15. So I can easily make both sides 15 by multiplying this side by 3. And I can multiply this side by 5. Alright, and when I do that, that gives me a common denominator. And I'll show you in a minute why that's important. So I'm going to go ahead and multiply this out. So I'm going to have 3x plus 12 over 15 times x minus 1. I have an equation, so I'm going to put equals to 5x plus 35. And that's over the same common denominator, 15 times x minus 1. Alright, now that I have a common denominator, when I have an equation, if I do the same thing to both sides of my equation, then they are still equal. So because this is on the bottom, it's like 1 over this, I can multiply both sides by my denominator, 15 times x minus 1, which is like this over 1, and it will cancel with my denominator. So if I multiply this side by 15 times x minus 1, that's again anything over 1. This is on the bottom, so it's like 1 over this, and this is this over 1. So this is on top, this is on bottom, and this cancels out. So by getting a common denominator when you have an equation, you can multiply by that denominator, and it gets rid of your whole fraction. So now we're left with 3x plus 12 equals 5x plus 35, and now this is just a simple 2 or 3 step equation. So I'm going to subtract 3x. So I've got 12 equals 2x plus 35. Subtract 35. So I'm going to have 2x equals minus 23. And divide by 2. X equals negative 11.5. Alright, now what were our excluded values? Since my denominator had a variable in it, so x minus 1, so the excluded value would have been 1. 1 minus 1 equals 0. The denominator cannot be 0. So we had x not equals 1. So we have an excluded value of 1, and then we have x equals negative 11.5. Now, let's see what questions we are given here. All right, it says, why are the numerators not used to identify excluded values? Well, the numerator can be 0. So the last statement here, the numerators are allowed to be 0, would be the correct answer. Only the denominators cannot be 0. All right, it says factor the denominators if possible. Find your least common denominator. So 15 times x minus 1 is what we found. How did you find the least common denominator? Well, we factored first and then seen what they had in common. All right, use the least common denominator to eliminate the denominators. So I multiplied both sides by the denominator and solved. And you can go through the math here and see they also got x equals negative 11.5 when they solved. All right, what would the solution be if the values were excluded? All right, there would be no solution, okay? Because if it's excluded, then it's not a solution, okay? So if it's an excluded value, it would not be a solution. All right, it says check your answer by writing each side of the original equation as a function and then graphing the two functions. All right, so if I graph the two functions, what part of the graph corresponds to the solution? All right, so the intersection point. Because we had an equation, they graphed the left side as one color and the right side as the other color, and they found the intersection point here. So you can see this is negative 5. That means this would be negative 10. And that means this would be our negative 11.5. So if that was on your calculator, you would have to kind of zoom in to find that point. Let's see. This is hard to see. Let me get rid of this. Let's see what this says. All right. What part of the graph corresponds to the solution? All right, the x-intercept of the blue function, the x-intercept of the red. Okay, the x values of where they intersect would be the two solutions. All right, that's all for task